Alright guys, we have this 2005 EZGO TXT 36 volt. This one has a couple of issues. The first issue is we have a leak in the tire. In fact, it's not actually the tire itself, it's the valve stem. Okay. If I can... Yeah, there we go. If I press it in hard enough, you can hear the leak stops. So we're going to change this. I'll show you how I do that. And the other issue this one has is the charger's not coming on when it's plugged in. So I was able to charge this card up with another charger that I have, another PowerWise EZGO charger. So this, I know, is not the cart side. It is definitely on the charger side. So let's jump into the charger. I'll show you what I found is going on. And you may experience this at some point. There's a couple of reasons why a charger wouldn't come on. Basically, your batteries are dead, and the charger requires a minimum voltage in the pack before it'll even turn on. So that's the first thing you need to check, is you need to check the battery pack voltage. The other thing it could be is it could be something inside the plug. I haven't had too many experiences where the plug has gone bad and it stopped charging, but sometimes the main charging wires, the positive and negative leads internally, break, and they usually break right about here because there's really no like actual strain relief. I mean, there's one built in here, but it does have a tendency of wearing out the cables in here, so it's possible that it could be the wires in here that are broken. And I'll show you how we test for that. The other thing it could be is the jack, the receiving end of this plug on the golf cart itself. Typically what will happen is there's a reed switch inside, and if the reed switch doesn't close, it doesn't turn the charger on. Those are common and they're pretty typical to fail. A lot of people just bypass them. So let's open this charger. I'll show you how to test for continuity between these pins and the inside of the charger to see if there's actually a break in the wire or if it's the charger control board. This charger looks like it's landed on the ground a couple of times. And these are all self-tapping sheet metal screws. There's one on the bottom, one in the handle here, one on this handle. Remove the handle, let's get rid of that zip tie. There's two on the back on the bottom here. There's one more here. Lift straight off. Oh, you can see the cap is a bit rusty. I highly doubt that's the issue. And what I'm looking for in here is to see if there's any, like there's a 50 amp fuse right here, but I'm just checking for obvious things first to see if... Alright, so when you get inside the charger, the first thing you need to look at is look at this fuse if yours is equipped. It's a 50 amp fuse. If it's blown, you'll know it. It'll basically be in pieces. Here is that sense wire that comes off of the red wire underneath the seat of the cart. Underneath the seat, here's that red wire, which there's a magnetic reed switch inside this socket, which is what engages this circuit. When the reed switch closes, it's what sends the signal to the charger to turn it on. Alright, so here in the charger we see this is our run capacitor, which sometimes these things can go. I mean, it's not all popped and bulged. It is rusty, but that doesn't mean anything. Just make sure our connections are good. Here's our control board. 9 times out of 10, that's what it is. Something happens with it, and it doesn't tell the relay to turn on. So here's how I do my preliminary test to see if that's the issue. This is our 120 volt line set right here. You can see our hot lead goes first into the transformer, and then from the transformer, or I'm sorry, it comes into the relay, and then out of the relay into the transformer. And then the other winding goes onto this board here, which is commoned to the neutral. And then our ground is chassis grounded, which is plug grounded, which is then grounded on this board as well. Let's do a continuity test first to make sure that we're not changing parts we don't need to change. Alright, so you get your meter. Any voltmeter, multimeter will do. What you want to do is you want to get on your ohms continuity test. Now what we're going to test for is continuity between the plug and our internal connections. We're going to go after the fuse, before the fuse. We have 0 ohms, so we want to test both sides of the fuse. We're going to touch our plate here. That's good, and we're going to check our diodes, which our diodes should kick out no reading at all, except for this side. Okay, so you can see this is basically a half-wave rectifier. Okay, so we have continuity on that side. Let's check this side here. we have continuity. All right, so that tells us cord set is good, so we don't have to worry about that. Now we're going to check our transformer. Okay, so we don't have an open winding on the low voltage, high current side. So now we're going to test by unplugging the transformer from the control board. If it wants to unplug with... Why is this not cooperating? See if we can... There we go. We have to unplug it anyway because we're going to be replacing this control board, I'm thinking. Alright, so here's one side of the high voltage inside input. Okay, so we're not open circuit. That's the important thing. Now we're going to check. I mean, this is a little bit of an in-depth test. Okay, we're going to check our common. We're checking the 120 volt cable now. If it'll let me. Okay, that's not open. Now we're going to check the hot side. Okay, that's good. Now we're going to just check the ground because this is our safety line. We're going to actually go to chassis ground here. Anywhere on this chassis should be okay, and we're good. So our line sets are good. The cord sets are good as far as not being broken. Now what I'm going to do to test to see, because I bet you this control board is shot, I'm going to bypass our relay. And I'm going to do that by taking our 120 volt cord input, and I'm just going to basically plug it in directly to the transformer. We're going to make this a tighter connection than it is, so we don't have any arcing. Even though it will not be under load, but we'll also do a voltage check too. Okay, so that's a nice tight fit. Now you can plug without touching anything. If you're not comfortable going in here and doing this, this is the disclaimer. Don't do this. Don't try this at home. I take no responsibility for you getting electrocuted because you're being a dumbass. All right, so now when I plug this in, you can hear the transformer is live. Our meter is not going to read anything because we have no current going through the DC side. This meter reads DC amps. All right, so now what we're going to do is we're going to switch our meter to volts, and we're going to measure our voltage. But as you can see, we have 44.6 volts DC coming in or out of the charger. We know the transformer is working. What I'm going to do now is we're going to put this back on AC volts. And the reason why I'm doing AC volt is because I'm going to test the output of the transformer. As soon as I untangle my meter leads here, we're going to do the output of the transformer before the split phase rectifier, or the half wave rectifier. So we should have, there we go, 42.4 volts on that side. Bad contact, that's what it is. 42.4 volts on that side. So we know our transformer output is good. Now we're going to go back to DC, and I'm going to measure the DC output. 44.6. Same voltage reading we got on the plug. So we know the transformer is good. The charger works. So that's what we know. We now have learned that our charger is functioning as it should. It's just the problem is our control board. So we're going to change the control board. First thing you need to do is, don't be an idiot, and unplug your transformer. Unplug it. Don't touch the cap because it will have residual. There is no discharge resistor on this. So here we have CGR026. It's a direct replacement. Looks exactly identical. It's not the exact same board. This is a newer board. It does come with instructions. Our panel is labeled, so white XF is transformer. Transformer, that's what that means. And green is ground. And then basically these don't matter which one goes to which, but just keep them the same because you have your line in and your line out, which your line in and load. And then this stuff here will connect appropriately once we get to that point. This is one of those things where if you're not 100%, hire a professional if you're not comfortable performing this type of work. It's better to have it done correctly than get hurt or cause a fire. Worst case scenario. There we go. Transformer. Unplug our leads here. sometimes they can be tricky, and that's good. If they have it come off, if they take a while to get off, like if they're difficult, that's a good thing. That means the connections are secure. I'm gonna discharge that. Capacitor's discharged, but still act as if it's 100% fully charged and alive. If you treat it live, as if it is live, you won't, or your risk of getting electrocuted is less. The transformer is not live. Transformers don't store electricity, so don't let anybody fool you on that one. A transformer by itself, I should say, doesn't store electricity. A transformer is designed to transform electricity. Typically, a transformer is used to step down AC voltage, which is exactly what this transformer does, is it steps down the 120 volts coming out of the wall down to 42 volts, 44 volts AC coming out of the transformer. It's AC, alternating current. There we go. Here's our old board. Just the boards fail. Now see, this resistor looks like it got quite warm. Yeah. What happened, look at it, you can see in here, this is where all of our problem comes in. Probably could repair it, but for how cheap these boards are, just replace it. Alright, so what we're going to do is we're going to take our brand new control board, and we're going to slop it in here, right on our standoffs. I'm going to take our red plug, go right back on the same plug we unplugged the original one from. We're going to take okay, that's a little too loose for my comfort. I'm going to tighten this up. I don't like loose terminals when it comes to electrical. Okay, nice and tight. Alright, that's plugged in. We're going to also take our 120 volts in. Yes, that one's loose too. If you have the opportunity to do this, just squeeze these terminals. Make sure they're firm. And then slide them on, and you're good to go. Much safer to be tight, because loose connections is what starts fires. Also, it's inefficient. Okay, there's our ground. Even if you're in here testing and you find the transformer is bad, but this is good. Here's our white. That's nice and firm. And now we'll bring down our transformer common. These are not polarized. They don't, doesn't really matter which one goes where. Well, in this case it does, because that one's not long enough. So that's the only thing that matters is, oh, I did it again. There. Okay. The only reason this matters is because of the length of the wires. How loose that's become, so I'm going to give it another squeeze. When in doubt, change it out. That terminal is still not tight and I don't like the way it feels. I'm going to change it. Okay, so there we go. A little bit of cable management. I'm going to run this wire underneath here, and then we plug this in. Got this really nice silicone boot on it to help keep the terminal protected. There we go. That's it. That's all there is to it. So now what I'll do is I will plug in our charger. Nothing's exploded. There's no sparks, no flames, no fire. First thing I'm going to do is turn this. So this meter should now light up. Now start moving it, so it's indicating that it's charging. There we go. Okay, there's our result. So as you can see, that was the problem. This cart is charged, so we're not going to leave it plugged in. This is just for a test. But you can see that's how easy it is to change out these charger boards and to repair your PowerWise charger. 9 times out of 10, that's what it is. I have never changed the capacitor in one of these yet. So, alright guys, that is it. That is all there is to it, to replacing the charger control board in your PowerWise charger. Alright, so I've unplugged it from the wall, I've unplugged it from the golf cart. Make it look good, you know? Take pride in what you do. Okay, so there we go. That's that. Looks a lot better now that it's nice and straight. Alright, so we're going to install the back screws. Don't have to go nuts with these because you will strip the holes out. Okay. So weird how these things are built. Like, you go to take a club car charger apart and there's 15 million screws. Take one of these apart, there's like 2. Okay. And then we take the handle, tap in like this. Last screw. There we go. Okay, so that is a result. That is a completely repaired charger. What we're going to do now is we're going to get that tire straightened out. I'll show you how I change those valve stems. If you guys are ever in the market for a really nice impact, especially a portable one, this Milwaukee fuel brushless uses these M18 batteries. This thing is a freaking monster. It puts my air impact to shame. I actually used this to change the tires on my RV. Because the air one wouldn't take them off. Now, the air one's probably just a little too weak, but whatever. Don't lose your dust cap either. I usually use that to put the lug nuts in. Perfect little bowl. Okay, let's go over to the tire machine. Alright, so here is my Chinese tire machine. Triumph NTC 460. It's all pneumatic except for the turntable. Turntable's electric. Get off to the side here. It's okay. It's not the greatest. It does the job that I need. I mean, it's a mess because it's been, it's pretty dusty in here. But I've had this basically since I've been in business, and it's after almost busting the teeth out of my face using one of them stupid ass Harbor Freight tire changers. That's why I went to one of these. But I don't keep air to it all the time, so plug that in. So open the jaw, take the tire, put the valve stem, mud on the back of the tire, god damn it. Get the hose out of the way. And put the bitey part of the jaw right there. I also keep a spray bottle of Dawn and water. Alright, so I have my valve stem here, and then I'll squirt it down with some Dawn and water. Put it off to the side. Take the cap off. You're going to need the cap to come off. And what I'll do is I'll take a pair of side cutters and I will see how it's ripping. Okay, so now that I have that, I'll squeeze the clamp on the wheel, on the tire, till the bead breaks. Oh, I gotta go turn the air on. Usually helps when you turn the air supply onto a pneumatic tire machine. Okay, so now we'll break the bead. Okay, and then I'll hold the tire right there, and I'll cut the back side of the valve stem, rip it off as best I can anyway. If I can rip the whole thing out, which here's the bottom, and I'll just pull that out of the way. And I'll take valve stem puller tool. Slide this in place. Thread it on. And then pull it into place and we're good. And now that the bead has been broken, I'll take some of my soap that I use for the tire lubricant. I think this stuff works the best. I've had no issues. Most people pull the core to seat the bead. A lot of times you don't really have to. I'll set that there and I'll kind of massage the tire a little bit. There we go. You can see, you'll be able to see on the tire where the bubbles are. That's where it's leaking. But usually when the bead seats, it's fine. That's how I also check for leaks. And we're going to go to 30 psi and check for leaks, and then we're going to drop it down to 20. Okay, there's 30. See no leaks on that side. Leaks on that side. And no leaks around the valve stem. Put that on for now. We'll take a tire. Let's go put it back on the golf cart. So now that we've established that there's no leaks in the work that we've done, we can first I always forget to do this. Our dust cap through our wheel. Then line everything up. I'll get these started. That dust cap just helps keep that nut nice and clean. And then we'll get it touching. One thing you need to keep in mind, I know I've mentioned this in other videos, got to make sure the shoulder on the lug nut is completely seated in the shoulder on the rim. Otherwise you're going to get a wobbly, it's going to wobble when you're driving it. It looks like we are good. I'm going to and it's a golf cart, guys, so you don't need to reef these down to 2,000 pounds per square inch. Just get them tight enough so they don't come off. Okay, so that's a result. Now all I got to do is just knock down the pressure in this, and then this cart is done. So we'll take this 30. Okay, so that gauge is pretty accurate. Knock it down to 20. Tire air stinks. There we go. That's a result. Alright guys, this cart is done. So alright guys, that is it. Tire is fixed. Just gotta rinse it off again. It's a little muddy from being outside. I washed the cart after I pulled it out of storage, so I wouldn't have to deal with that, but because of all the rain we've had, everything is just flipping wet. So, alright guys, I want to thank you for watching. I really do appreciate it. Like the video if you liked it. Subscribe to my channel if you haven't already. Be sure to check the links in the video's description down below, where I have links to products I use every day to bring you these videos and to run my business. Also check out my website, Facebook, and Patreon pages. Thanks for watching, guys. We'll see you in the next video.